deepest fathoms of the ocean. In the frozen landscapes of the boreal regions. In the restless souls of rivers. In the relentless waves of the coast. Even in the very bowels of the earth. Water moves. It envelops the planet in a fine vapor that is unevenly distributed. It forms paths, facades, and spirals or puffs of white that float softly by. Water vapor floats gracefully above the earth. Beneath the clouds, turquoise, blue, and green oceans and seas swell and surge. "75% of the Earth's surface is seawater. That is the hallmark of our planet. And it is the oceans which make Earth so special in the universe." Another effect of water vapor is that both poles and the highest mountain peaks are tinged with white. Water leaves its liquid mark wherever it goes. Water is a strange mineral that can move and travel across enormous distances, changing its physical form. Water has many faces, and it appears in every corner of the earth in a different guise. Ice, thousands of years old at the poles or in the mountains. Vapor clouds which could vanish in an instant. And liquid water which runs through valleys, filling lagoons or seas. What is clear is that water is a mineral that flies, flows, and floods into its destination. It stays for a while, and then it's off again. This is known as the water cycle, which began a very long time ago. Water and the planet have been closely intertwined since the very beginning, when they were both created. The components of that primitive hot Earth already contained water vapor. The planet was a globe in a state of fusion, where thousands of volcanoes were spewing out lava and steam. The Earth's surface was a harsh, white-hot place where there was no room for life. Its atmosphere continuously received vapor, which was held in suspension. The bowels of the Earth gave off vaporous air, which slowly began to condense in the air. The temperature was so high that the clouds gathered and traveled across the sky without being able to shed a single drop of water. Then, at some point, the Earth cooled, and the menacing storm clouds transformed into constant rain, which lasted for several centuries, until oceans were formed. Those ancient seas contained the water we drink today. Scientists believe that the quantity of water on Earth has remained constant since the dawn of time. That means that the water we drink, or that's held in the clouds, is the same water which gave life to the dinosaurs and the ancient seas. The water which formed a vital ingredient in the magic cauldron that created the first living beings. Water made life possible, and as it traveled, so did life. Let's learn something about the never-ending journey which made water the messenger of life. The seas and oceans contain most of the Earth's water. They hold 97% of all water on the planet. And they are home to some of the most primitive creatures, descended from the first fish. But there are also some highly innovative animals which have evolved very effective camouflage to protect them from predators, or to allow them to be better hunters themselves. The oceans are vast deposits of water, but they are far from being peaceful or tranquil places. Violent currents rip through the oceans over thousands of kilometers, and the surface of the water is whipped up by winds and the swell of the waves. And it is from this vast store of salty water that the water cycle begins. The heat of the sun evaporates the surface water, turning it from liquid into gas. The seas and oceans create about 90% of the vapor from which clouds are formed. The major advantage of the evaporation process is that it distills the water and rids it of its mineral content. That's why water in the sky is extremely pure. Clouds are constantly on the move, but occasionally they get held up on their way, and it's usually mountains that are the culprits. The low temperatures cool the clouds, turning them into snow or water. In some parts of the planet, snowfall is a common occurrence. The ice and cold have produced some of nature's most effective winter coats. In winter, animals which live in circumpolar regions are not much bothered by temperatures well below freezing. Frozen water can also form glaciers. Environmentally, they are very important because they are a vast reserve of fresh water. Of the 3% of water that is not found in the oceans, 2% remains frozen in glaciers. Sooner or later, water melts, and after a couple of centuries inside a glacier, it begins to travel again and is swept up in the water cycle. Again, it is the sun which provides the energy required to melt the ice of the glaciers or the mountains. molecule of water can end up in some pretty unpredictable places. For a while, it might quench the thirst of a macaque in the Atlas Mountains on the edge of the desert and form part of its body. Or perhaps it will just follow its usual route. During the winter, it was high up in the mountains, forming snow and covering the high-lying areas with white. Now, it might form part of a mountain lake with its pure, cold, crystal-clear waters, where very few animals and hardly any vegetation can survive. It won't be long before it drops into a mountain pool or stream. It's on the move again, but not for long. Its path is interrupted by waterfalls, whirlpools, and currents, which give strength and speed to the water of the streams. It will only slow down once it becomes a great river. Yet it is estimated that a water molecule would only take between 2 and 6 months to travel from the river's source to the point where it joins the sea, even if it is part of the Nile, the longest river in the world. Rivers and streams are extended ecosystems full of life, where the flow and speed of the water vary. These two factors mean that each stretch of the river is different and is home to very different types of plants and animals. Each species looks for the ideal spot to live, feed, or mate. And each one makes the most of what the river can offer. For example, the roach mating season is a plentiful time for snakes, which can easily catch them to boost their energy during the winter. But there is another important part of the cycle that is not seen because it is under our feet. Groundwater can remain under the Earth's surface for long periods. It is thought that when a water molecule is trapped in the subsoil, it might remain underground for some 10,000 years. Groundwater, the sea, and glaciers contain over 99% of the Earth's water. The quantity of liquid in rivers, lakes, and clouds is not very high. In fact, it is barely significant, since it represents much less than 1,000th of the planet's water. Yet it is this tiny quantity which makes life on Earth possible, and which shapes and fashions the landscapes in which we live. All creatures that dwell on the land rely on this continuous, insignificant flow of water. And the water cycle is the driving force of our lives. But water is unpredictable. It is an elusive element which does not always take the same route. Sometimes it becomes scarce, and the earth becomes cracked and dry. While in other seasons it is abundant, or even too plentiful. In the hottest, most humid climates, vegetation plays a part in the water cycle. Leaves in the rainforest release huge quantities of vapor into the atmosphere, causing severe tropical storms. Normally, every drop ends up in the river, which closes the cycle by joining the sea, giving back the water which was previously a cloud. But its waters look quite different now. Muddy and murky, they guard many secrets as yet untold. For water, so ubiquitous and abundant, conceals many unknowns, lending mystery to this strange substance, which is more like a living creature with a mind of its own than an inanimate mineral.